let's see whether we can get the hex to come out. So as you recall, in Lab 5 for CS240 here, we had a number which the user typed in, for example, like that. We read it into a register, EAX, and then we printed it out in binary, and then we printed it out in hex. And in order to do that, in order to get the binary out, we needed to print this as a string of 32 ASCII characters for the binary, ASCII zeros and ones, okay? Now if we have 32 bits, we need to print out 32 bits in hex. A 32-bit hex number is going to be what? There's 4 bits per hex digit, so it's going to be 8 ASCII characters to represent the 32-bit number in hex. So we need to have a buffer with 8 ASCII characters. Fortunately, we have at the top of our skeleton program, hexbuff is 8 bytes for the 8 ASCII characters. Now, we have another thing up here which is going to be useful, which is we have a label called hexdig. Hexdig is the label of the first byte of a 16-byte string. So there's 16 bytes in memory, and we put there the ASCII 0, the ASCII 1, the ASCII 2, and so on through the ASCII F. Now, if you actually look in here, I wrote 0, 1, 2, 3, 4, but I put quotes around it, right? As if these were quoted, right? If I actually look in memory, this ASCII 0 will actually be what? It's a hex 30, right? So hex blob. Then we get to A, which is 61. So 62 through 65, 66. Okay? So, and the 9 is going to be 39. Okay? So, the character 0 is in memory 1 byte hex 30. The character 1 in memory is 1 byte hex 31. The 9 is a hex 39. Okay? 57 decimal. The A is a 61, 97 decimal. The B is a 62, 98 decimal, all the way through F, which is a 66 in hex. Okay? So, hexdig is 16 bytes of memory containing the 16 ASCII characters. All right. The setup is the same. We're coming into the hex convert. I have your bind convert here for reference. You come into hex convert, and EAX contains the number that you want to convert. In this case, we're imagining that the top 4 bits of the register are 1010. 1010, we want to print what? We want to print a letter A, right? Okay. So, the first thing we're going to do is get those 4 bits to the bottom. Now we're going to do the rotate thing again. So now we're rotating by 4 bits. These 4 bits rotate left, end up over here. So they're rotating one at a time. The 1 goes here, and then it shifts over, and then the 0 comes in and shifts over, and then another one, okay, like that. So think of them as one at a time rotating, this one, and then this one, and this one, and this one, okay? And then these other bits, they all shift over 4 like that. So that's the rotate. We're going to move it into EBX so that we can do that, work with it. And where's my orange one? Here's my orange one. I'm sorry, this was in EBX. This is like this. My apologies, I screwed that up. 1010. Okay, that should be an orange, but that's okay. So in EBX, we have our number, and we have a lot of other crap up here. And what we want to do is we want to get this so that this other crap is, you know, whatever this is, 1, 1, 0, 1, 0, blah, 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 blah. We want to get it to be zeros, and we want to get only this part here. Just like we did with the 1 bit, we were concentrating on 1 bit. Now we're concentrating on 4 bits, which is 1 hex digits worth. Okay, so we're going to AND it. We're going to do the AND thing again like this. Again, this is an AND mask. Let me write that. Everywhere there's a 1, that number gets saved. Everywhere there's a 0, that number gets 0. That bits get zeroed. So if I AND all this, here comes 0, 0, 0, 0, and then 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0. So that's my 4 bits. That's the bits that I'm interested in. Okay, so this is 4 bits. What's the value? 1010 is decimal 10 or hex A. So what I need to do into my output buffer, my 8-byte output buffer, we're going to put my 8-byte result string, the 8 ASCII characters for the hex number, is what I'm going to need to do is I'm going to need to get an ASCII A into that byte, right? Okay. Now I can't just add hex 30 to this. So I add hex 30 to this, I get, hex, if for the binary it worked, because 30 was a 0, 31 was a 1, okay? Decimal 48, decimal 49. If I add 10, this is a 10, this is 10. The value is 10. If I add 10 to 48, I get 58. 58 is not, it's an ASCII character, but it's not the right one. If I add a hex A to 30, I get 3A. 3A is that ASCII character. It's not A. How can I convert these 4 bits to the table, the number that I want? And I'm going to do what you would do in a high-level language. In a high-level language, you could do something like get a 16-byte table, a 16-byte array. Okay. What I want to do is, I think of this as a hex digit is a 16-byte array. I want to get item number 10 out of that array. This was item 0, item 1, okay? Item 15. So I'm going to go into this array and grab item number 10. All right, how do I do that? Well, in assembler, the way we do it, and this we're doing it, I'm just showing you here kind of in a little more detail than you need, because the assembler actually gives you a shortcut or two, but in order to understand it, we're going to unshortcut it. So what we're going to do is we're going to get the address. We're going to get the address of the first byte of hexdig. The address at the beginning of our array, we're going to get that into EDI. That's move hexdig, which is that label. Okay, we're going to get that address into register EDI. So when I do that, okay, EDI over here is going to point to the beginning of hexdig, the green one. EDI is going to point to the hexdig. EDI over here is going to point to the beginning of this array. Next, that's an address. It's a number, right? I can add this thing. EBX is a number. It happens to be 10. I'm going to add 10 to EDI. And add whatever number I got here to EDI. So what happens? EDI now points to someplace 10 bytes further along in memory. Originally, EDI pointed to that first byte where the label hexdig is. Now EDI is going to point to 10 bytes further along. If it was 0, it's still here. 1, 2, 3 is going to point to that byte there. So now EDI is going to point to that byte there. EDI now contains the address of the letter A in memory. How convenient. We can now load the letter A out of memory, 61 hex, there it is in binary, into the BL register, which is, remember, it's the low byte of the EBX register. So we're just going to go to that address which we've just computed, load that A, stick it into BL, and then we can put BL into memory just like we did before, into the output buffer. So now we're going to get 61 here, which is letter A. Okay. We'll move increment ESI. We're going to loop again. We're going to loop 8 times now, right? We'll increment ESI to point to the next guy. Okay. We'll shift this over 4 more bits, get the next 4 bits, okay? We'll take the next 4 bits, we'll mask them. We'll get a number out. That's going to be a 6, okay? We'll take the 6, we'll add it to the beginning. We'll load up the beginning of hexstage again, add 6 to it. We'll go 6 into 6 past the beginning of, and we'll get an ASCII 6 character. And then we'll put that 36. Okay? So it's the same kind of loop, except instead of taking 1 bit, converting it to an ASCII character with some arithmetic, and sticking it into an output buffer, we're now going to loop 8 times. Each time we're going to grab 4 bits. We're going to do this table lookup. We're going to go into this array by doing this address arithmetic. It's called address arithmetic, and grab it, and then that will be our hexstage routine, an 8-bit loop where each time we mask 4 and look up a byte. Happiness? Okay. The last part of that lab is to print out whether the original number was positive or negative. So in the lab, they print out the number according to your conversions. They negate the number. You can see the negative of that number in binary and hex, and then print out whether that original number was positive or negative. So in the demo, a little bit of demo program that comes with the lab, it contains code to see how to test whether it's positive or negative. Okay, you do some operation to it and check, just like with the if statements, and do a flags register jump if signed or not signed, like that is how it works. And the other bit of code that's in there is a little bit of code that does the same kind of thing that we just did here, except it does it only 2 bits at a time. So it takes 2 bits, moves them over, prints out, okay, like that. It takes 2 bits, moves them over, does a table lookup, so 0, 1, 2, 3, like that, prints them out. Got it? All right, thank you.